The demonstration of the course project of CS F222, which is also known as Discrete Structures in Computer Science. Um, our problem pertains to professor to course assignment, and we have used two approaches to solve this problem. One is the Hungarian algorithm, and other is the integer linear programming. Both of them have the same input file, so let's just look at the format of the input files. We require two input CSV files. One is the course file. A course file looks something like this. It has three columns. One is the course code, type, and sections. Sections represent obviously the number of sections for each course. The type are of four types: FDCDC, HDCDC, FD electives, and HD electives. Please remember to name them in the correct format, or else the code will not run. Second, we also have the preferences CSV, which is the preferences that the professor assigns. The format for this is the name of the professor, the category to which a professor belongs. Categories are essentially integers from 1 to 3, where 1 represents 0.5 course assignment, 2 represents 1 course, and 3 represents 1.5 course. We have other columns of FDCDC, HDCDC, FD elective, and HD elective. It doesn't matter how many preferences you put in them, but please remember to follow the same format. Moving on to the video demonstration of the working of the ILP algorithm.
So now I'll show you how to run the ILP program. For this approach, we have used integer linear programming along with the Google OR Tools software suite, and more specifically the CP-SAT solver. What's unique about our approach is that we can easily relax and add additional constraints, so it is easily extensible. Now before we begin running the program, we need to install the dependencies. So for this we create an external environment using python -m venv my environment. After you create the virtual environment, we have to install OR tools. Pip install OR tools. This will also install NumPy and pandas. As of recording this video, it will work with the latest versions, but in the future you may have to refer to the specific versions listed in README. Now we can run the program. So driver.py takes two command line arguments, the preferences and the courses. If we give only one command line argument, it will only take the preferences and use the default courses, and if you give 0, it will use both of the inbuilt defaults. Make sure your output.csv file does not exist, otherwise it will append it to the bottom of the file. As you can see, the program is running successfully and we have got a total of 27 solutions. Now let's look at output.csv. This is output.csv. As you can see, in the first row we have total cost along with the names of the professors. Total cost is the first column that indicates the total cost of the assignment. A higher cost means a better matching in which more professors have got their favored courses. Now we can see under each professor the courses they have been assigned is listed. We also noticed that the total cost is in ascending order, that is, the most optimal assignment is at the bottom, and in this case it is 6,360.
Discuss the Hungarian algorithm implementation of the program in Java. The Hungarian algorithm is used for one-to-one course assignments, but in our case we've extended it to many-to-one and one-to-many assignments by applying it recursively for CDCs and elective courses. To use the program, you need two input files, which Vrishti has already explained how to populate. You need to store these in data/courses and data/preferences respectively. You can provide two custom files for your preferences and courses. In this case, you put the preference file as your first command line argument and your course file as your second command line argument. You can also provide just the input file, in which case samplecourses.csv will be your default course file. And you can also provide no arguments at all, in which case the default files will be used for both preferences and courses. To use the program, compile all the Java source files in the folder using javac star.java. After this, run the program by running Java driver with the command line arguments we explained. Uh, the file path to the output file is printed to your terminal. The output file is very similar to the one used for the ILP implementation, but the metric is different and it's arranged in descending order. Uh, you cannot compare solutions between the two files because the metric is calculated differently, which is explained in the report. This is an example of just one test case, but our testing has been much more extensive than this, which Vrishti will explain to you in a moment.
We have run our program against various test cases, which include some of the edge cases like what if there are too many professors and too less courses, or too less professors and too many courses. What if there is no professor who has assigned a particular CDC, like the CDC doesn't even exist in the preference list? What if a professor has not provided any preference at all? Our code takes care of all these edge cases as well. For more information, you can refer to the README and the report. Also, please note that our approach is more generalized than the problem statement and can be extended to any university with a similar course structure. Thank you.